Hello, welcome to Matlab for Beginners class. In the previous class, we looked at functions. We also looked at predefined variables and complex numbers. Today, we are going to look at matrices and vectors. The outline for today's class includes introduction. We'll look at matrix multiplication, addition and subtraction, inverse of a matrix, determinant of a matrix, and solving systems of equation. Now, Matlab can store several numerical values in a single variable. And these are mostly referred to as arrays. So Matlab, however, treats these variables as either a matrix or an array. So when it is treated as an array, Matlab addresses these variables like other conventional programming language, and it performs element by element operation. So when it is treated as a matrix, so Matlab performs matrix operations with the variables. Okay, so in matrix calculation, if let's say you want to multiply in a matrix, you take a row of one matrix and multiply it with a column of another matrix and add the result. But when it is treated as an array, you multiply the one element by element. So now let's look at example. So let's say I have a matrix A is equal to, then I have 1, 2, 3, 4, 5, 6, 7, 8, 7, 9, 8. Then I have B is equal to 8, 7, 9, 6, 5, 2, 3, 4, 1. So if Matlab wants to consider these two matrices as an array, it will take first element and multiply by first element, second element by second element, and third element by third element. So it is going to do element by element. If it is taken as a matrix, we will take a column, multiplying a row, a column multiplying a row. Then we know that this is a matrix. So if we want to perform operations in matrices, we use the normal operators. We use the star, the plus, the division, the slash, the minus. If it is in array, and if it is an array, you put a dot before the operator. So a dot star, a dot plus, a dot backslash, and so on and so forth. So now how do I represent this in Matlab? So in Matlab, I will type my A is equal to, then I'll use a square bracket. Square bracket, then I will do row, so my row is 1, 2, 3. Then I'll put a semicolon in between them and move to the next row. So 4, 5, 6. A semicolon, and the next one is 7, 8, and 9. So for the next one, which is B, I'll repeat the same thing. So I'll do 8, 7, 9, comma, then 6, 5, 2, comma, then 3, 4, 1. So now let's move to Matlab and try to type some matrices in Matlab and see whether it will appear in the form of a matrix or it will appear in the form of something else. So let's say I have A is equal to, open a square bracket. My numbers are 1, 2, 3. Let me leave space in between them. 1, 2, 3. Then I'll put a semicolon. 4, 5, 6, semicolon, 7, 8, 9. So now let me press enter. So if I press enter, it is giving me my first matrix. So now let me type a second matrix. So let's assume the second matrix is 9, 8, 7. I put semicolon, 4, 4, 3, 2, 4, 3, 2, semicolon, 1, 6, 5. So 1, 6, and 5. I have to close it with a square bracket. Let's press enter. So now we have our second matrix. So now let's move on to perform some matrix multiplication. So to perform matrix multiplication, we use the star. So if I type C is equal to A star B, it will multiply A by B. If I say C1 is equal to B star A, it is going to multiply it by A. So I can also say C2 is equal to, let me multiply by a scalar, and my scalar is 7. So 7 multiplied by A, and it is going to return an answer. So now let's move back to Matlab and perform these operations. So we said C is equal to A multiplied by b. So it has multiplied it and given us an answer. So now let's do C1. Let's find out whether matrix multiplication is commutative. So we have B multiplied by A. We press enter. We realize we are not getting the same thing. So now let's try and multiply it by a scalar. So C2 is equal to a scalar which is 7 multiply by A. So it has been able to multiply with a scalar as well. So now let's do matrices addition and subtraction. So now with the same functions that, with the same matrices that we have, let's try and perform D is equal to A minus B. D1 is equal to A plus B. Then D2 is equal to B plus A. And we can also add a scalar. So D3 is equal to a scalar 8 plus A. And let's see if it will be able to perform this operation. Okay, so we are finding D. D is equal to, let's say, A plus B. A plus B. It has been able to add N. We've gotten an answer for D. Then D1 is equal to A minus B. Let's press enter. It has been able to perform the subtraction operation. Then we have D2 is equal to B plus A. Sorry, I typed the wrong equation. So D2 is equal to A so it's D2 is equal to B plus A. So it has given us an answer. So looking at the 2A plus B and B plus A is giving us the same answer, meaning that matrix addition are commutative. Now let's multiply it by a scalar. So D3 is equal to a scalar 8 plus A. So we have been able to do scalar we have been able to add a scalar to the matrix. Now let's try and let's try and find the inverse of a matrix. So to find the inverse of a matrix, we use a command called INV. So INV, then INV into bracket the matrix. So INVA should give me the inverse of A. Okay, so now if I do INVA, I'll get my answer. So let's say E1 is equal to INVA and E2 is equal to INV, sorry, E2 is equal to INVB. So now let's move on to Matlab to perform the inverse. So we have A1 is equal to INVA. So we have the inverse of the matrix. We have E2 is equal to INVB. So we have the inverse of the matrix. So if I want to generate a random matrix, I'll use a command called rand, R-A-N-D. So if I type rand m, n, it creates an m by n matrices. So now let's see if I type rand 1. Rand 1 will generate a single matrix. So rand, if I say rand 2, so it has generated a 2 by 2 matrix. So if I also say rand, the bracket 3, 4, and I press enter, it will generate a 3 by 4 matrix. So now that we know about the inverse of a matrix, let's find the determinant of the matrix. So to find the determinant of a matrix, we use the command det. So if I type det, then the matrix, it will calculate for the determinant of a matrix. So now let's try again to find the determinant of the matrix. So let's say det A. So that's the determinant of the matrix A. So det B. So det B is equal to 30. Now the last thing we're going to look at is solving system equations. So in the field of engineering, most of the time you'll end up with a system of n equations with n number of unknown variables, and you need to solve them. Matlab can help you solve this equation easily. So now let's consider a system equation. So our system equation is 6x plus 5y plus 3z is equal to 2. Say this is our equation 1. Now I have another system equation, which is minus 5x plus 4y minus 6z equal to minus 32. We say this is equation 2. And my third equation is minus 7x plus 5y plus z is equal to 7. So let's say this is equation 3. So these are my system equation. So in matrix notation, this system can be written as Ax is equal to B. So now our A will be equal to, or A represents the coefficients of all the variable in the equation. So the first coefficient is 6. We have 5. We have 3. Then we have minus 5, 4, and minus 6. We have minus 7, 5, and 1. Then my b is also, or my small b is equal to the resultant. So I have this, I have 2, I have minus 32, and I have 7. So 2, 32, 7. Then I have my value for x, and x will be representing all the variables. So I have 6x, sorry, I have x, I have y, and I have c. So these are my system equation. So now if you take a course in algebra, you will be able to develop the relation that exists in this equation. So this function ax equal to b has a solution if the rank of a and the rank of b okay, so if the rank of a and the rank of the augmented matrix, that is the matrix A and B are both equal to 3. So now we need to test and see whether these matrices are equal to 3. If they are equal to 3, then it means there lies a solution for this matrix. Okay, so this was 32 instead of 3, it was 32. So if that is the case, if they are equal to 3, we have several ways of solving the equation. Now the first way of solving the equation is to find x, which is equal to, you find the inverse of a multiplied by b. So this is the first method for finding the solution. Now the second method is x is equal to a, then we use the backslash operator multiplied by b. So now this is the second method for solving the simultaneous equation. So now let's move on to matrix, then find the rank to see if they are the same. Then we can move on to use these two equations to solve for the simultaneous equation. Okay, so now let me clear the screen. So now let's type the two matrices, that is the matrix of A and that of B. Then we find the rank. So A is equal to, remember we use a square bracket, then we have 6, 5, 3, and semicolon, then we have -5, 4, -6, then another semicolon, then -7, 5, and 1. So this is our first matrix. So now let's press enter to see the outcome. So now we have the matrix displayed. Now let's do B. So B is equal to, so we open a square bracket. So now B is a column matrix. So if you type the first number, you put a semicolon, then the next one. So -32, semicolon, then 7. So now let's press enter. So we have the second matrix. So now let's find the rank of A. So I will use a command called rank, R-A-N-K, rank, into bracket A, and I'll press enter. So the rank of A is 3. So now let's find the rank of A and B. So rank, so now rank, then open a matrix, open a square bracket to find the matrix A and B. So you close the square bracket and you close the other bracket. So we press enter and we are getting the rank to be 3. So it means there is a match. So now let's use the two methods which we talked about to find the solution to the system equation, so to the simultaneous equation. So let me find, we are finding the values of x. So x is equal to, I'm finding the inverse of A. So inverse A multiplied by B should give me the solution. So after pressing enter, I've gotten the solution to the system equation or the simultaneous equation. Now let's use the second formula to validate the first answer. So x is equal to A backslash B. Let's press enter. So we are getting the two answers to be the same. Okay, so now let me give you some examples to go and try at home. So given that you have a system equation or simultaneous equation, 30x plus 40y minus 66z is equal to 70. That's your first equation. Now 35x plus y minus z is equal to 60. That is equation 2. Then x plus y minus 60z is equal to 80. That is your equation 3. So use the knowledge you have acquired to solve this system equation. Next video, we are going to look at strings. Thank you very much for watching. I do appreciate you all. Please leave your valuable comments at the comment section. And please